This one? No, we're not graphing this stuff. What we're going to be doing is this. How do you undo squaring? You agree? Okay. Kinda. Yeah, don't worry. Yeah. But it looks like this then. Yeah. So what we're going to do now is, instead of just working with regular old square root equations, which we have done, we're going to have nth root equations, which means we can have cube roots, fourth roots, 2/3 roots, 7/8 roots, pi over 4 roots, things like that. So, actually, but we'll have all these different roots with equations, but you still solve them the exact same way. In this case here, what do you think you have to do first? Add 4, good. So we add 4 to both sides, you get the cube root of x is 4. Not cube, it's cube rooting now. How do you cube it? Remember, to undo cube rooting, you cube. What's 4 cubed? 64. Okay? Don't get your hopes up is what you're saying already? You know me too well. All right? Okay. There you go. 2x to the 3 halves equals 250. 2x to the 3 halves equals 250. First thing you have to do is get x by itself. So that means you have to do what? All right, divide by 2. What's half of 250? Good. All right. Think about how you moved fractions in the past. How would you undo fractions? All right, multiply by the reciprocal. How do you think you're going to undo a fraction exponent? You're trying to say the right thing. You're going to do the exponent reciprocal to both sides. So what is the reciprocal of 3 halves? 2/3. So you 2/3 root it. Now, in your calculator, 125, oops, to the, remember the little caret button? In my calculator, I'm going to put it in parentheses. I can do 2 divided by 3. There you go. Yeah. So I'm taking the cube root, or the 2/3 root, and I get x equals 25. Now, how do you know if you are right? What are you doing, electrical work? What is it called? Substitute. So, bear in mind, to make sure that you're not doing silly mistakes, substitute back into the original. So 2 times the quantity, 25 to the 3 halves, equals... Wow, did you press the buttons? So it works, okay? The reason why I'm showing you guys about this checking stuff, you will have to start to check some of these solutions. Because what you're going to have sometimes are called extraneous solutions. Extraneous solution means it looks like it works, but it doesn't work. Yes, sir? Of course. Come on now. I've done 2 examples, and they're a piece of cake.
If you have like it's to the negative 3 halves, would it still be 2/3?
It'd be negative. You just put the, yeah. Great question. Holly was saying, if your exponent is negative, if it was a negative 3 halves to start with, to undo that, you multiply it by negative 2/3. Because what you want to do is you want to create an exponent that is equal to 1. Okay? So don't think in the back of your mind you have to do opposite reciprocals. Just do reciprocals. Okay? The only thing you worry about opposite reciprocals if you're working with perpendicular lines with slopes. Okay? Here we're just doing reciprocals. Alright? So, the square root of 4x minus 7 plus 2 equals 5. Okay. What was the first step? Okay, good. Subtract 2. So I have the square root 4x minus 7 is 3. Square it. Very good. So you square one side. What do you do to the other? Square it. The square root of junk squared is? What's the junk? X equals 4. So far, so good? Okay. Check it. Make sure you're right. 4 times 4 minus 7, take the square root, and add 2. 16 minus 7 is 9. 9 plus 2, or 3 plus 2 is 5. It works. What's that? Where's the fractions? I know she's not. That's why I'm laughing. Square root. 3x plus 2 minus 2 root x equals 0. This is where things start to get a little bit trickier. Because notice how many variables you have? 2. So what you're going to wind up having to do is you're going to have to set this up to have variables on both sides of the equation. Okay. So what do you want to move? Add the 2x. Good. So you have the square root of 3x plus 2 equals 2 root x. Get rid of the radicals. Square both sides. Now, when you square this side and that side, square root of junk squared is junk. So this one's easy, 3x plus 2. This is where you're going to make your mistakes. Remember, use the rules of exponents. 2 root x squared means the same thing as 2x, or 2 root x times 2 root x. Or think of it this way, 2 squared square root of x squared. Okay? It's 4x. Okay? Everybody see what I did? How that worked? You got to be careful on some of those because you will see values out in front of your radical. You have to remember what that means when you square it. I think the easiest one to remember is using that power rule where you're distributing the power to both terms. Sometimes students remember that a lot better than they will writing it out twice. Okay? All right, so now what's x equal to?
2. What if you had like negative 2 to the third power?
You'd cube both sides.
What if one was squared and one was cubed?
I don't think you're not going to work.
So if it
Yeah, I don't think you're going to have that. No, we're not going to have that. All right? Yeah, that's really, really, really all sorts of bad. Okay. So now, what's the next step you're going to do? Yeah, substitute in, check it and see if it works. So you wind up with 3 times 2 plus 2, which is what?
6.
What's the square root of 8? And what's 2 root 2 minus 2 root 2?
0.
So it works. Okay? That's the first step before the trickiness starts to happen. I wouldn't say 17, more like 5, 2, I don't know. Extraneous solutions. Excuse me. This is where checking your answers comes into play all the time. And the instructions on all the stuff that you have for homework that you'll see on quizzes or tests and stuff will always say check for extraneous solutions, which means it's wanting you to just double check to make sure it does work. Okay? So you have x minus 4 equals the square root of 2x. So the first thing you have to do is what? Square it. Good. So you square both sides. Now, when I square x minus 4, quantity squared, what do you get?
X squared
X squared minus 8x plus 16 equals 2x. Remember, ladies and gentlemen, you have to FOIL it. Okay? You got to FOIL it out. Okay? Now, set one side equal to 0. What are you going to move? So we have x squared minus 10x plus 16 is 0. So this is setting up to be a problem where you have to solve for your zeros. So what times what is 16 that you add together to get negative 10? Yeah, both negatives. Good. Negative 8, negative 2. So that means your possible zeros are 8 and 2. So that means you just have to check to see which one works. Do they both work? Do none of them work? That kind of stuff. So we have, go back to the original equation. You have 8 minus 4. Does that 8 equal the square root of 2 times 8? Well, that's 4, and that's the square root of 16. So yeah, 8 works. Okay. Check it with 2. We have 2 minus 4. Does that equal the square root of 2 times 2? Well, that is negative 2, and that in this case we have just regular 2. Does that work? No. What's your only solution? That's your extraneous solution. What they're looking for here is going to be all your real answers, okay? Because you don't want to deal with any imaginary stuff. I don't think the second semester we had any imaginary problems whatsoever, so that should be good news to hear. So it's not going to be, it really isn't going to be anything that's going to scare you off. But the trick is that you have to just spend that extra minute or two at the very after you're done with the problem, just to resubstitute in, just to make sure that it works. Okay? And that's what's called checking for your extraneous solutions. All right, so yeah, it sounded like a whole bunch of weird words, but I just straight you through. All right. Not so bad? All right. Try some. Try some. Let me pause this real quick. All right, let's check. What's the first thing you did on number 7?
Add 16.
Good. So you have 4x to the 2/3. Divide out by the 4. X to the 2/3 is 4. So then you have to rehab it. So think of it this way. Remember, the denominator is the nth root. So what's the square root of 4? What's 2 cubed? Or you can just use your calculator.
Yeah, 16 also.
I got 8.
Yeah, 16.
Yeah, 16.
I got 8.
Did you divide by 4? You get
16 works.
I got 8.
4 to the 3 halves. 8.
It was 16 words.
Yeah.
That's just dumb luck.
I got 8.
I did. 1.5. Did you put parentheses around it?
You don't shoot 8.
You forgot the 1.
Number 7.
Oh, I got
Oh, there's the 3 button. Yeah, thanks. Really? Okay. Operator error, maybe? Okay. Then you substitute back in, and it should work, I believe. I don't think any of these were going to be wrong. Number 9, what'd you do first? Add 1. Good. You add 1. So you have x plus 9 to the 5 halves. So 32 to the 2/5 power. All right, what is the 5th root of 32? 2. 2 squared is 4.
Minus 9.
Yeah, and then this one does work too. I remember checking these earlier. Okay? All right. All right, let's do some more. Okay. On number 11, what do you need to do first on number 11? Subtract 6. Now remember, the reason you have to do that is because you cannot undo any of this stuff until this equals something. Okay? So you have cube root of 3x is 4. Cube it, you get 3x is it 64? Okay? So x is 64 over 3.
Yeah.
Okay? Fractions.
You're
Fractions.
just supposed to like round it.
Yeah, because what happens though, well think of it this way, when you substitute back in, you wind up with the cube root of 3 times 64 over 3. What happens? It drops out. The cube root of 64 is 4. 4 plus 6 is 10. So don't round it. That's why you keep your fractions. Because the calculator isn't as smart as you. And the last one here. What are you going to do first? Subtract 5. So you have 5th root of 2x plus 1 is now 4. Due to the 5th power. 4 to the 5th power is the same thing as 4 squared again, so that's 256. 1024.
Yeah.
So
That is 511.5.
Yeah. That's what I got.
okay, good. Now remember, and you guys are saying, what do you do for checking your answers? When you substitute this in, you have 2 times 1023 over 2 plus 1, and then you take the 5th root. Notice, the 2's are going to drop out, and you wind up with the 5th root of 1024, okay, which is 4, and you add 5, and you get 9. So even though you're getting these weird fractional answers, when you substitute in to check for your extraneous solutions, the fraction should go away. Okay? Not so bad? Since we have a couple minutes left, let's just do 14 and 15. Okay? Let's just try 14 and 15. Yeah, go ahead. Let me pause this again so I don't keep eating up all the form pain. So let's quickly look at 15 before we run out of time. Here, you've got to get them equal to each other. So you have 6 root x is root x minus 1. Square everything. So what was it on this side? 36x. Equals square root of jump squared is? Jump. I've not squared anything because remember this. Add 1 divide, subtract 1, so 35. X is -1. X is -1 over 35. So right away, can you take the square root of a negative number? No, there's no solution. All that for nothing. Literally, all that for nothing.
Do you have any notes?
Of course you will. Why wouldn't you? You never know.
Why isn't it? Why is the answer supposed to be over 35?
Because when you substitute this in here, you can't take the square root of a negative. Okay, try those. 441, 24 through 52 evens.